All right, hey everybody. Um, so this is a quick little addition to the kind of finish a lab. So anytime we do a lab, we're going to start out with a question. In this case, the question is, how does mass affect the distance? I don't know what the lab is. I just made it up. But you're always going to be saying, how does one thing affect something else? And we want to answer that question. And we start out by creating some data from a model. And I've done that. And I've put my data into QuickGraph. And this is all something you should be able to do. All right, so it looks like my first setup here is, I'm going to make this mass, because how does mass in kilograms affect the distance? And this will be distance in meters. Now, I like to put these here because it makes my graph look good. And I need a good graph to answer and finish my explanation on my lab report, which I'm going to show you in just a second. So anyway, we've got my data. So the next step here is to curve fit something to this. So we'll pick a curve fit here. And I'm going to pick linear. Yeah, not great. I see a curve up. So let's try squared. Pretty good. Cube, not so good. And then all the others definitely not going to fit. So squared is the best graph for this thing. So now I've got my graph, distance in meters, mass in kilograms, and my equation, y equals 2.016 x squared. Right? So now we take this over to our lab report where we change it into physics. What does all this mean? Okay, to write a lab report, this is what a lab report is going to look like. You're not going to make this for each of your data sets. You're just going to do a small thing for each one. But just to go through it, you need a claim. The claim is the answer to the question. And I'm going to show you really easily how to write this claim in just a second. The data section is where you might put in the, just kind of sketch it in, data. So you'll have the data table right there. So I got the data table, and I'll fill that in, labeling the headings, and I'll also put a sketch of the graph. This particular graph looked like that, and then I had the labels. All right, so I got my labels in there. Quick sketch of the graph. So far, oh, and then finally A. A is always going to be what is the math model that was created by this. In this case, the math model was, and I want to do this one out. The math model was y equals 2.016 x, and I'm just going to write 2 for squared. It was square, but it's kind of hard to write in this thing. All right, but that's not how we do it. We instead, to write the actual math model, it's not y, it's distance. So I'll write distance equals 2.016, and it's not x, it's mass, m squared. So it's not x, cross off x, no x, it's m for mass. So I took the first letter of each of the things and made it a variable, and that got my math model. Okay, so this is where you've gotten to. We've started to answer a question of how does mass affect distance. You got some data, you got a graph, you got a math model. B is always going to be some sort of extension question that says, well, what would be the distance traveled if the mass were some value that you didn't and can't test? And so you use it, you plug it into your math model and solve for it. But C is where we further explain what this is. So the rest of today's kind of lesson is going to go into what you write in the claim, and what C. And C is going to be, what does that constant mean? All right. Okay, so I don't have a way to get rid of this and bring it back, so it's going to have to sit right on top. The first thing you want to go to is, I know it's really annoying, the cheat sheet that I just put on here. If you click on Lab Graph Cheat Sheet, it's also one of the claims, constants, and units of constants. You'll get a file called Graph Linearization. It's really the graphical methods summary. All right, I got rid of that, saved it, and I'll pull it back up in a second. On this sheet, you've got 4 columns. The graph shape. So the key here is just to go down and find the shape of the graph that you care about. For this particular setup, I've got this squared shape here, so that'll be the graph I use. I can see the next column here is called written relationship. This is actually what I'm going to write for my claim. As x increases, y increases in a squared relationship. Except I'm not going to say x and y, I'm going to say as mass increases, distance increases in a squared relationship. And that'll be exactly what I type in there. So I'll do that in a second. Next column is units of slope. Now, I say units of slope, really it's the units of the constant. And this is a weird little equation that you have in here. I'm going to show you how to use this, but you basically take the units, if it were linear, you take the units of y over the units of the x axis. If it were an inverse, you take the units of y times the units of the x axis. If it's a squared relationship, which it is, we're going to put the units of y over the units of x squared. And that'll be the units on that constant 2.016 that we'll put there. And so that's what we're going to do today, these two things. I want to write a claim, I'm going to add a claim, and I'm going to write the constant with units. It's that simple, and this will be the square that I'm referencing. Okay, so I have written in the claim section the answer to the question, how does mass affect distance? As I found, as mass increases, distance increases. That's easy to see, but in a squared relationship. So there's my finding. That's my claim. That's what I can now say based off of what I did. A, my math model, D equals 2.016 mass squared. And so then C is, what is my constant with my units? Eventually you're going to describe to me what that means, but for now I just want to know what the number is. So if I want to type that out, I'll type out 2.016 because that's my constant. There's the number. I pull that right out. And now I need to add some units to that. Now, the units were, let's actually use text. The units from the sheet, if I jump back over to the sheet there, the units said, for the squared one, y divided by x squared. So the units of y over the units of x squared. Well, the units of y are mass. So let me write that real quick. You're not going to write this every time, but the y divided by x squared. That was the thing I need to pull over here. But again, it's not y and x. I want the units of y and x. So it's going to be 2.16, and then the units on 2.16 are going to be units of y, meters, so meters per, or divided by, units of x squared. So per kilogram squared. Kilogram squared. And that's it. That is all you needed to do. You need to add a claim, and the constant with units to that. So you're going to go back, copy and paste the data, reproduce the graphs. So 1, 2, 3, 4 for each one. And I'm even going to do number 1 for you. So first off, it's Wednesday's assignment. So it's grayed out right now because you don't have it yet. But Wednesday 9/9. If I click on it, you'll have what your assignment is. But I'll jump right over here to the data graphs and math model. You're going to open it up, and you're going to look at it, and you're like, wait a minute, Mr. Rager, we already did this again. I know. I want you to just snag it. I want to show you one other feature of QuickGraph with this that you can do. So if I've got my data sets, and this is how you should take your data when you take it. I've got the first data set number 1. So this is the exact same numbers, 1, 2, 3, 4, 5, and 6 as you had on the sheet. So I want you to do this whole thing. Data set 1, I've got my volume, meter cubed, pressure, and pascals, PA, units, and then I've got the data column right there. The reason I've written it so funnily, that's even a word, is so that you can get it into QuickGraph pretty easily. So if I want to do data set 1, I'll just select and select all those, Control C, or you can right click copy, either one. I Control C. You open up QuickGraph and you go to import data. If you click right there, and then I'll just paste it, It puts all those numbers right in there. And then right here on the x-axis, I tell it the x-axis is volume, the y-axis is, and I say it's pascals, and it imports it right in there. Boom, boom, and it plotted the points for me. So I didn't have to enter any of the data into the iPad. I just copied and pasted. It imports it right in, and now I'm ready to curve fit. So I'll grab my curve. I'll try inverse squared. That didn't work. I'll try inverse. Inverse nails it. So I've got my good graph. I know it's going to be an inverse graph, and the equation is y over 4x. So then I jump back over to the assignment. I will start writing. I'll do a quick sketch. Sketch the graph. I'll say my math model is, it's not y, it's p. P equals 4 divided by volume. And you can write this out too if you want with the marker or whatever. So that's the part we already did. Then I want you to write your claim and what's the constant with units. So with the claim, I'll go over to my cheat sheet. Yep, it's going to stay here. I'll go find the inverse graph. So this is this one right here. And it's as x increases, y decreases inversely. And then I can see my units of my constant are yx. So I've written as x increases, but it's not x, it's volume. As volume increases, pressure, P, if you don't know what it is, you can just write P, decreases inversely. There it is. I've written the claim using the cheat sheet for this. So that'll be something you need to add, and then constant with unit. So the constant is 4. I want the units of that constant. Well, I can just type in constant is 4, and then the units. If you look back at the cheat sheet, I can see that the units of the cheat sheet on the cheat chart were yx, but it's not y, it's PA. So the unit will be PA x meter cubed, M3. And I didn't use P and V, I used PA and M3. I didn't use the variables, that's for an equation, I used the units. And so that's all I have. So we're going to have 4 things that you need to add and do to each one. You need to do the graph, the claim, the math model, and the constant with units. All right, and do that for each of your data sets and hit submit on this. And that's Wednesday's assignment.